Harvard and working on a very complex math problem. Oh, he must be very smart.
You need therapy from Robin Williams.
Yeah, but I'm gonna reject him at first and be mean to him about his passed away wife.
Those are your defenses from your rough childhood.
Right, but it's not my fault.
It's not your fault. Hey, it's not your fault.
Stop it.
Don't you know?
Stop it.
That it's not your fault.
Stop. Oh!
Do you get it now?
Yes, all my problems are fixed.
That's all that it takes.
Then you make a movie about it. That was actually their relationship in real life at the time.
No way.
Oh no.
You know, I didn't realize that it was about a guy named Will Hunting. I thought it was like, hey, you're gonna go hunting? Here's Goodwill. I didn't know. I just didn't know.
You just didn't know. It's not your fault.
There is no way for me to know. Don't you see that?
I see that. I also see that every time you exhale, the breath goes out the eyeball holes of that mask and fogs up your glasses.
Well,
I really hope they can see it, but unlikely.
That's how lions work.
Oh, they breathe out of their eye holes?
Yeah, did you not know that?
I didn't know that, but it's not my fault.
Hey guys. Oh no, I don't know how to turn that off. That's on you.
What did you just do?
No, there's just something that needs to be
Oh,
invisible.
okay.
Yeah, it's just
Jeez.
your other thing.
I thought you
Hey
like-
guys, welcome to Nerdish. I'm Brady.
Oh, it's going. We're going. Okay.
Yeah, this
Got
is
it.
Levi.
Hello, I'm Levi. You know me.
Yeah, and you all know me. Why would you say it like that? They know who I am. I'm Brady.
I made my the going live notification on Twitch. Where are the rabbits?
Why?
Which is what on that Facebook page of moms and dads that are for
Yes.
town, right? Someone posts just a post on that page. Where are the rabbits?
That was all I said.
Yeah, that was it. I didn't understand it at all.
That's
I
fun.
still
How do you
don't.
get this over there? I forget all this.
Yeah. Well, that's
Yeah.
new, so yeah. So you go
Preview?
No, it's that.
Full projector window thing?
Yeah, and then hover over that, and then it's
Display 3?
2 actually.
Cool.
Yeah. Pretty
All right,
crazy,
guys.
huh?
Well, I'm Brady and I'm signing off.
Ready, signing off.
Yep. Yeah.
Cool. Yeah. There we go. Okay. What do we got here? We're live. We're very live. I wonder who's here. Perhaps nobody. Oh, I need to post on Discord, don't I?
Yep.
Uh-huh. I'm gonna post on Discord, so those... Hey, Slice, how are you? Slice, you have questions? Did you figure out if that discrete math question that you had worked for you? Was that the right answer? How do we do this? Still have no idea. Okay, cool. Good to see you too. We're doing that button? Yes. Awesome. Cool. Yes. Ask your professor. Hey. Okay. So, is there any older math for you that you're not as comfortable doing, Slice? It could be anything really, but ideally on the SAT or ACT, which you may or may not know. Slice, are you in the UK? I wonder why there's so many UK people. You may not be in the UK, but you may be. Everybody's either in or out of the UK. Restream. No, I'm not in Hungary. Oh, I'm in Hungary. Oh, okay, cool. Where did that go? Think like not discrete math. That's not what it's on. People have trouble with, oh, there it is. Oh, it's working. Okay, great. People have trouble Often with let's see. I mean, okay. Do you want to talk about math, or we can do English? Do you have any plans on coming to the U.S.? King Jason, hello, my liege. Epic gamer moment. I don't know what that means, but yes. EGM. Do you have any questions, King Jason, about the SAT or ACT? I feel like... Hey, here in the moment. Welcome. Oh, you're planning to come to the U.S. for masters. Cool. Why? Why? What do you want here? King Jason, you're only in 8th grade. They raised you so young. So young. I remember... Nah, I don't want to go in that direction necessarily. Okay, you're only in 8th grade. That's fine. What math are you in? Because maybe, I'm sure, some of the math you're doing is on the SAT. USA is the home for computer science. Ah, this is true. And programming in general, also true. Go over systems of equations. Yeah, here in the moment, do you want a system of 2 equations? How do you feel about, like, we can start with this. Let's do this. I have quarters and dimes totaling let's say that's not what I meant. $8 and what do we want to say here? Okay, I'm giving you a word problem so we can build the system and then we can solve it. So I have quarters and dimes totaling, where did I get total E? Nope. $8 and 15 cents. So how can we figure out the number of quarters and the number of dimes? Oh, and let's say, let's leave it there. So you could probably kind of work this out, but there is a way to set up a system here. And now we want to say specifically that we have, there are sorry, I just need to do this in my head. I need to write this down here so I can figure this out later. Say 9, 15. And then bear with me. I will be done with this setup in about 30 seconds fully. We have that. And then we need another. Ooh, that's not right. Maybe it is. No, it's not. Let's change this number to $10. Okay, so if we change that number to $10.15, and then we say number of dimes number of quarters is 6 more than the square root of number of dimes. How many dimes and quarters do we have? Can you solve systems of equations with a matrix? Yes, you can. I don't think that's necessarily the most useful skill for the SAT or ACT. So I don't necessarily want to talk about it here. I think you need to be able to solve systems with elimination and substitution for sure. Okay, so it may seem like a hard question. And that's because this is a little bit intimidating. But as soon as you see that you have a word problem and they don't give you a picture or anything, and there you have quarters, you have dimes, we're going to figure out how many unknowns we have, and we're going to build an equation. The SAT and ACT, but mainly the SAT, is all about building equations. So that's what we want to do with this. Now, we don't know the number of quarters, and we don't know the number of dimes, and that's what we're looking for here. We need to set up two equations now, because we have two unknowns, so one equation is not going to be good enough to figure out what both of them are. Let's do the second part first, this part. Let's build an equation using Q, which is quarters, number of quarters, and D, which is number of dimes. Okay, so to build this equation, we have 6 more quarters than the square root of the number of dimes. So this is difficult. We're going to work word by word. The number of quarters is. That's where you want to start. There's a way to translate from this English to the math. Number of quarters. We said that's Q. And then we say is. That means equals. 6 more than something. So that's going to be something plus 6, or 6 plus that thing. So square root of D plus 6. Exactly. Perfect. Good job. So that's one equation. Now the other equation is slightly messier possibly. Do you know what that would be here in the moment? Or anybody else for that matter? Oh, did I really not do that yet? I'm going to post on Discord real quick. Who just joined? Oh. Announcements. I'm just making an announcement. You got it. You got the other equation? What's the other equation here in the moment? Let's do. At everyone. Nope. Everyone learn live now. Q plus D equals 10 plus 0.15, or sorry, 10.15. Close with the 10.15, that's correct. So you have 10.15, but that's the amount of money you have. So if you do Q plus D, that's not going to give you an amount of money, that's going to give you a number of coins. So we need to figure out how much money you have in quarters plus how much money you have in dimes. That means if you have 4 dimes, you're going to have 40 cents in total, right? We want this is going to be in dollars here. Let's put it into cents. We'll do that later. So this is $10.15. What we're going to do here is do 0.25 times Q, because every Q is worth 25 cents, right? So we can't just have Q plus D. We need 0.25 Q plus 0.10 D. Hi, Boss Dad. How are you? Does this make sense here in the moment? This will give us the amount of money in each of those things. We add them together to get to the 10.15. I will then make this slightly simpler. Well, we don't have to necessarily. Let's leave it as is for now. Okay, it makes sense. Good. Now you have this system. If this is the calculator section, honestly, because you had a radical in here, I would just graph both of these and then find the intersection. But that would also mean you need to manipulate the second equation anyway. I am well, Boss Dad. I am quite well. I have a headache, but I'm fine. It's all good. Okay, so now we're going to solve this equation. Matrix stuff here would be super annoying, so I would say use substitution. That's going to be relatively straightforward. So let's take this Q This equals q. Let's plug it in for this q right here, which would give us 10.15 equals 0.25 times 6 plus radical d plus 0.1 d. Okay, now this is going to be pretty ugly pretty fast, which is a bummer, but that's what we're dealing with here. Okay, next step, I'm going to distribute that 0.25. So we get 10.15 equals a quarter of 6 is going to be 3 halves. 3 halves plus radical d over 4 plus, I'm going to do that as, let's just do, d over 10. That's the situation here, yeah? Now, this is going to be pretty ugly still because we have decimals, we have fractions. I'm going to multiply everything by 10. Sorry, by 100, actually. And I actually probably should have done this sooner. Multiplying by 100 just gets rid of all the decimals and all the fractions. Here in the moment, please let me know if that doesn't make sense to you. I'm just making this easier to look at. You could feasibly graph this, plug it into your calculator, whatever you want to do. There is faster stuff. But let's do this. We get 10.15 equals 3 halves is 1.5 times 100 is going to be 150 plus 25 radical d plus we have d over 10 times 100 would be 10d. Okay, so now we're here. This is still not great. I don't love it. But from here, we keep going. This has radicals in it, so you have to deal with that. So what I'm going to do, I don't know if I want to do this difficult a system of equations. The substitution that I did over there, are you comfortable with that? Because that's the main part of systems of equations. This is a very difficult equation to solve anyway. We did the systems part, now it's just an equation. Yeah, subtract 150, so 865, right? Something like that. 865 equals 25 rad d plus 10d. Sorry, I don't know what the I don't know is for. Yes, I get the substitution. Okay, from here, what you have to do to get rid of the radical, you have to square it, but you don't want to square it as we have it here. We want to isolate the radical d and then square both sides. It's going to get ugly, and then you'll factor at the end. Do you want me to continue on in this, or do you want to see another just probably simpler numbers-wise equation or system of equations? Don't say yes or no. Tell me specifically what you want. You want another systems of equations that is easier numbers just to practice it, or do you want to see me finish this? Also, other people, definitely ask your questions. Also, I have to send a message online real quick. Please, an easier question. Yes, okay, I'm going to get rid of this. I wanted to show you a little bit of of building a system of equations. Now, this one's just super difficult to solve, but building systems is super important. That is on the SAT every single test. At least one, sometimes two systems of equations. Sometimes they'll give you, it's multiple choice, so maybe they're not even asking for the answers. They just want what are the equations or what is the system of inequalities. They will give you a handful of those on every test. I like these questions. That's why I brought it up. Okay, so let's do another one. The way to deal with systems, I honestly generally gravitate towards substitution every single time, unless there's something really glaringly nice to do with elimination. Otherwise, I recommend sticking with substitution. Slice, what's up? Oh, the stream's behind. How involved is calculus in the SATs? Yeah. No calc on the SAT. Or ACT. Okay, so let's do, I'm just going to erase this part for now. Again, I apologize, Brady's not here. It's obviously way more fun with him here, but do what we have to. Ethan. Took the SAT last week. When are you taking it again, Ethan? Hello, by the way. Calculus is nice if you like pure number math and not so much geometry, in my opinion. Ethan, yeah, I would say take a break. If you're feeling burnt out, take a break. You just took it, wait for your scores, see how you did, then pick it back up in January. January, February, March, it's the beginning of March. 2 months is a good amount of time. If you feel super behind, you don't have to do the whole thing, but maybe if you're really struggling in one area, do some secondary work, like do some cross-training sort of. So if it's math, do a bunch of math on Khan Academy on, geometry if that's your biggest issue. Or if it's not that and it's the reading section, then read a bunch of articles over the next month or so. Do that instead and, focus on something else instead of burning yourself out on the SAT. How do you boost about 70 to 80 points in reading? Read a lot more. And we can talk about the sections, the question types and the passage types if you want. You've been here before, right, Ethan? Really bad at finding angles. Okay, we can do angle stuff too. But let's do another of these systems of equations. So let's say we have... Nope, I just showed you what I was going to do, so I'm going to change it. Okay. Let's say 2 minus x equals 3 plus, let's see. Okay, so that's equation number 1. So we have angles. Let's do angles next. Ethan, if you want to stick around through the explanation of this system, we can talk about reading stuff, or you can just come back in January and we'll do it then. Although, to be completely honest, Brady and I are, I'm going to sneeze. Ooh. Excuse me. Brady and I are considering what to do with the stream, but we'll be streaming in January most likely. After that, I'm not as sure. Is this what I want it to be? Yeah, okay, so that's fine. And then let's say 3x minus 2y equals... Okay, here's our system. What do you recommend we do first here in the moment? Yeah, just do that, Eden. Take a break, do other things. That's a good call. Just give yourself some time off. Oh boy. Then so isolate x in the first question. Yeah, let's do that. So if we isolate x in the first equation, I assume you meant, we will get let's see, we would get x equals, we'll have negative 4y actually, and then 3, negative 6, negative 13, negative 15, 15. Yeah? How are you guys so nice? LOL. Most people usually don't do this for free. Well, we also don't do it for free. This is free, but that's our tutoring company. So we tutor kids, privately, and get paid for that. But we like this, and we just want it to be bigger. So the problem with us doing it is not that it's free. It's just that we're putting in a lot of time to help kids for free, and it's not helping that many people. This could, ostensibly we could have a stream with a couple hundred people watching and asking questions, and that would be super fun, and that's not the case. So at a certain point, it does feel like it's not quite worthwhile for us. Where did the 15 come from? I think I did the math right. So I'm isolating this guy up here, so maybe I'm wrong. If we bring the 2 to the other, so we have 3 minus 16, that's negative 13. Subtract 2 is negative 15, and then multiply by that negative 1 to get x alone, we should get 15. Does that make sense here in the moment? It's just messing with this equation up there. Then you said plug it in, I think, right? Cool. So now we're going to take this, and we're going to plug it right in there. When we plug that in, we get 3 times negative 4y plus 15 minus 2y equals negative 11. And then we'll just have to work through here. Cool. So we get negative 12y plus 45 minus 2y equals negative 11. And then let's subtract 45 from both sides and combine these y's here. So we get negative 14y equals negative 11 minus 45 is negative 56. If I did this right, 14 does go into 56, and it does. Y will equal negative 4. So we just found y. Now we need to find x. You can plug it into any of these equations. It doesn't matter which one. Let's just choose this one because it's already solved for x. So we have x equals negative 4 times negative 4 plus 15. That would be x equals 16. No, sorry, y is 4. My bad. Y is 4, y is 4, and then negative 16 plus 15. So now we have x equals negative 1. So that's the answer to this system of equations. Does that make sense? Oy. Cool. So are you comfortable with how this translates to the graphical side of things? What does this mean? This x equals negative 1, y equals 4, that's the solution to this system. What does that mean on the coordinate plane? How would you define that situation? You got it. You just need to practice it. Okay, cool. Yeah, just keep practicing. If you Google, system of equations practice, you'll get tons of stuff. Khan Academy is fine for it. Just systems of equation worksheet. I'm sure Google has a bunch of free results. Okay, so I assume you're saying you don't know the question about graphically doing this. The solution to a system of equations is the intersection of the graphs. All right, so these two functions, I don't know exactly what they look like, but we do know that on the coordinate plane, they're going to cross at the point negative 1, 4. Negative 1, 4. They will cross at that point. And there is a logical reason why. So actually, I can graph that. What? What Oh no, I can't. That's x equals whatever. Okay, so why is the stream so far behind for you? I don't know. Try refreshing. But you're going. I don't know exactly what these look like, and I don't really want to find out. But you're going to have one graph that looks like that, and then maybe the other graph looks like that, and they both cross at this point here. And that's because, you know, there's going to be one point where that satisfies both this equation and that equation. Yeah? That's the definition of a solution. Like this point, these points, -1 and 4, if you plug it into this first equation, it works. If you plug it into the second equation, it works. Just like if it's on this line, it's got to satisfy the equation. If it's on that line, it's got to satisfy that equation. The only point that satisfies both is that intersection point. So that's the relationship between these two. Now, it's important to think about this graphically, because if you have two lines that are like that, they're not going to have an intersection point because they're parallel. Or you can have two lines right on top of each other. If you have two lines on top of each other, then they have an infinite number of solutions, that system. So be careful when they ask you not for the solution to a system or an equation, but the number of solutions. The number of solutions is very important. All right, so let's move on from this. I'm happy to do angles unless, who is that? Ethan, are you still here or are you gone? If you're gone, farewell. Let's do angles. Okay, let's do it. So what about angles trips you up? Is it just, you know, those weird geometry pictures of just all these different lines going different places and triangles and circles in places and you're just uncomfortable dealing with that? Or is it like you don't know? I think that's basically what's on the test. Or is it trig? Like, is trig you're not into trigonometry and those functions? Complex ones. Okay, let's do some complex stuff then. Hopefully I can come up with random stuff like that. That's nice. Here in the moment, remind me, which, are you taking ACT or SAT? You've told me a dozen times, I'm sure. But of the things I put in my head, that's just not one of them. Ah, okay, so ACT, yeah? Cool. Let me fix this real quick. Okay. Let's see, what can we draw here? Use this one. Let's do something like that, something like that. Let's make those the same. Then let's, yeah, let's do that and that. And that and that. And let's say that this is 140 degrees here. Can you read that? Yeah, so that's 140 degrees, that angle. And then this angle here is 51 degrees. You can maybe see that. Can you see that? That's 51. Make that a little clearer. And then let's say that that's a parallelogram. What is the measure of this angle? How about that? You like that? With these, basically the approach is fill in everything you can, and you have to think about all the rules that you might need. So let's write up a bunch of rules that you might be referencing. So, or types of angles and relationships and things like that. So we have supplementary, we have complementary. Let me know if you don't know what any of these are. We have vertical angles. We have everything that goes along with parallel lines cut by a transversal, like corresponding angles. Just write them out. Corresponding. Alternate interior. Same side interior. Those type of things. What else we got? Okay, we have sum of angles in a triangle. What do we got? That is so funky. What's funky? You don't like it? Oh, this is funky. Wow, you are super delayed here in the moment. That's frustrating. Okay. So that's just some of them. Some of angles in this. We have parallelogram rules. Things like that. You don't like it. Okay. So now let's just start filling things in. We don't have to know why we're doing it or if it will definitely help us, but we know we have this information here and we need to get over to the x degrees, right? So we can work one of a couple ways. We can work backwards or we can work forwards. I think both of them can help. So basically, if we don't know what x is, we want to figure it out. If we figure out this angle here, we should be okay. Because if we know this one is, let's say, 100 degrees, then we know x has to be 80 degrees because they're supplementary, right? They're linear angles, so they're supplementary. Ah, you're on mobile. Okay. Well, hopefully you can see these things. So we know we want to get there. How can we get that? Well, we can keep working backwards that way, but let's work forward. Let's work from these numbers here. If I know this is 140 degrees, then I know that this has to be 140 degrees over here because those are vertical angles, right? They're across from each other in this intersection. Then up here, this is going to be 40 degrees, and this is going to be 40 degrees because they're supplementary to those guys. So this will work. Let me know if that's no good. And because you're delayed and anybody else, just be very specific about what part you don't understand if I go too fast on something or if I make a mistake, which is pretty common. Now, here's a biggie. Oh yeah, isosceles triangles. I want that one too, because that's something they like to pull out, especially the ACT. Isosceles triangles. Now, the thing with isosceles triangles, it's very important. We know that the definition of an isosceles triangle is if these two sides are congruent to each other, because isosceles is two congruent sides, then those two angles are congruent. It's the ones opposite the congruent sides. Those angles have to be congruent as well. So it doesn't matter what the triangle looks like, as long as two sides are congruent, that means that the two angles are congruent. Yeah? So that's what we have here. Anytime you see an isosceles triangle, often it's going to be one of these directions. Either you know the two angles that are congruent, so you can say that their opposite sides are congruent, or you have the two congruent sides, you can find their opposite angles. In this case, we have these two sides here and here are congruent. That means that this angle is congruent with this angle. But we don't know either of them. But we do know that the sum of the angles in a triangle is 180. Knowing that, we can say, well, they have to add up to 180. We already have 40 up top, so that means we have 140 left over. These two have to split that 140 equally because they're congruent to each other, so that means that it's going to be 70 in both of these spots. Now, 70 degrees here and here. Let's just keep moving. We know that this angle, now this looks like it's just kind of going this way randomly, so it's not going to help us with the x, but let's put it in anyway. This will be 110 degrees. This will also be 110 degrees because those are supplementary, these two, and then these two down here are supplementary. Now, this guy here, you can say, well, 110 is supplementary, or you can say this 70 here is vertical. Either way, this will be 70 degrees. Now we have a 51 that's put in there. We know that this down here is going to be 51. We know that this here would be 129. This is 129. This here, that angle, is going to be the third adder. What? Okay, these three angles, the 70, the 51, and whatever this is, have to add up to 180 because all triangles, their interior angles add up to 180. So 70 plus 51 is 121, and then we have to get to 80, so that leaves us with 59. So that angle there is going to be 59 degrees. Let's do the vertical one here. That's also 59 degrees. This angle here will be the supplement of 59, which is 121, as we said before. 121, 121. So I'm filling all of this out, and it's getting very messy, but we're moving in the direction of x. There are some of these that maybe you can intuitively know that's not going to help me, so I'm just not going to write it in. That's fine. But if you're not sure what's going to help it first, just start filling it out. Now, we're here with this parallelogram. Parallelograms, the opposite angles are congruent. But you don't necessarily have to know that. You can use transversal rules here to immediately get the x degrees, because we know that we basically have these two parallel lines of the top and the bases of this parallelogram. Those are parallel, and then we have this transversal here, and that's cutting them, so we know that the corresponding angles have to be congruent. So that means that x is 59 degrees. And then we're done. We can fill in all the other angles as well if we really wanted. But we're not gonna. Does this approach make sense? You're just filling in everything. That's most of the stuff you need to know for geometry. Transversal rules are weird, especially when, I feel like people are used to seeing, okay, here's this line, here's that transversal. Well, I know that this angle is congruent to that one. Those are corresponding. I know that this angle here is congruent to that angle there because those are alternate interior. But only when it's drawn like that super clearly. Can you fill out the rest of the parallelogram? Yes, I can. I'll just do it in blue to change things up. So parallelograms, because this is still the two parallel lines cut by a transversal, we have this angle here and then this angle here. Those are same side interior, meaning that they're supplementary. Or we can say that this angle is supplementary to that one because it's a linear pair. So we have 59. This would be 121 degrees. And then we have all this other, like it's the same set, but now we have parallel lines this way cut by that transversal, same side interior. This is also 59 degrees, and this is 121 degrees. And now you can see. The light is seen. If you are not here in the moment, you're being ridiculous because you're watching me talk to here in the moment, which is fine, cool, but you're not asking your own questions. You should ask your own questions. Tonight's stream is sponsored by loneliness. Loneliness, part of this complete breakfast. Yeah. Yes. The angle, technically it's congruent, but for the SAT, ACT, equal and congruent are equal and congruent to each other. It doesn't matter. On the tests. You know they mean equal, that's fine. That's good enough. Oh, wait, what? Okay, makes sense. I'm thirsty. Give me a moment. Oh, that's super disappointing. So I think we used, well, we didn't use complementary angles, but we used supplementary, we used vertical, we talked about corresponding. At the end, kind of did alternate in the same side. We definitely did sum of angles in a triangle is 180. We did some parallelogram rules, which is less common than the other ones here. And then we did isosceles triangles. But basically, you're just going to throw all of the angle rules you know at anything like this. Anytime you get a picture, just fill it in with everything you know. You're going to throw math at it as much as possible, and something might stick. That's the approach. Do you have more questions here in the moment? You can answer any more math you would like. Yes. I got so much time here in the moment. So much time. I got nothing but time. That's not true. If you are done with questions for tonight and nobody else is asking anything, then happy to sign off. If nobody's going to make use, that's totally fine. Come back tomorrow. So if you have questions now, great. If you don't, then we got tomorrow. And then Brady will be back next week, which is good because I am getting a little bit of separation anxiety. Although I talked to him on the... No, I texted him today. I did not talk to him on the phone. I think that's it. Okay. Well, that's fine. Does anybody else have any questions? If you have no questions, that's all right. I mean, maybe I'll check on Reddit, see if there's anything particularly juicy. Otherwise, I'll just call it. Give me a sec, I'll find something. None whatsoever. It's not that I really want to, but logic is fun. I like logic. Logic is an awesome class. Whoa. Okay, let's do some Reddit situation stuff. What did you study? I majored in theater, and here in the moment I started this, majored in theater, and I minored in computer science and French. So, did study CS. It's awesome. It's super awesome. Nothing on our SAT. Ooh. Okay, cool. All right, so that seems like it. If you have any last questions, ask in the next 10 actual seconds from when I'm saying this. But have a good night. Bring questions for tomorrow. It doesn't have to be math. It can be English. It can be reading. It can be science. It can be essay stuff. We haven't talked about essays in a while. But yeah, bring stuff in. That's cool. Have a good night, everybody. And maybe I'll see you tomorrow. Maybe I'll see you next week. Brady will be back next week. Brady will be back next week. Night, Slice. Night here in the moment. Night, anybody else who's watching.